Hi girls, how you doing? Just a couple of, I suppose we're just doing another example now of KC calculation. This one's a little bit trickier. I've given you a couple of examples already of exam questions that calculate KC or get you to calculate KC, and we've talked through them. And this is kind of the next step. So before you watch this, you should have made sure that you've watched those three and that you've attempted the questions in your textbook and in the past papers that I mentioned. There's no real point in looking at this until you've done that. So this is the next step. And what this is this is about the type of question where they give you KC and ask you to work back to calculate the amount of material either used up or available at equilibrium. So the easiest way to go through this is to do an example, really. So the example I've picked, as you can see from here, is 2019 question 11b. So you may want to stop the video at this point and have a look at that one. I've written it out here for you. This is the equation that you're given. We've got bromine chloride reacts to produce bromine and chlorine. You're told that there's 0.2 moles in 5 litres of bromine chloride at the start, and then you're not given any other information other than the Kc value. So the Kc for this equation, which you should know already, is bromine plus chlorine divided by bromine chloride raised to the power 2, as you can see. And we're given that in the question, 0.220. And really this type of question is all about then working backwards and calculating these values, okay, when you're given this. So from a chemistry point of view, it's no different. From a maths point of view, it's a little bit trickier. So we're going to have a go at doing that together. Well, not together, obviously. I'm here, you're not. But what we're going to do is, as you can see, I've written it out again here. 2 bromine chloride and bromine and chlorine, and we've got the exact same table. Okay, so we've got a table here like we used yesterday, the amount initially, the amount that's used, the amount that's at equilibrium, and the concentration at equilibrium. And I've just written this in for myself here to remind me that it's 0.2 moles in 5 litres. I'm going to need that later on. Okay, I've also written in the corner that equation that you just saw a second ago, just to remind myself what it looks like, because I'm going to use that later too. All right, so what are we told in the question? We're told in the question that we have 0.2 moles of bromine chloride there initially, and there's no bromine and no chlorine at the start. That's fine. Now, normally in the questions that we've done in the past, we're given some information for these boxes here, how much is at equilibrium or how much is used or whatever, right? There's nothing, okay? There's literally nothing given to us in this question. So what we're going to have to do is use X and work back and solve it. So the amount of bromine at equilibrium, we're going to call that X, like that. So I'm going to put X there to represent the amount of bromine at equilibrium that's present. Now, because these react 1 to 1, because there's the same amount of bromine as chlorine, we know there's also X amount of chlorine at equilibrium. All right? And because, as we can see from the molar ratio here, there's twice as much bromine chloride used to produce the bromine and chlorine, it means that the amount of this that's used is going to be 2X. All right, so see what I've done? I filled in X and 2X there. And now I can work out how much bromine chloride is left at equilibrium, because that's going to be equal to this, what was there initially, minus what was used, which is 0.2 minus 2X, like that. See what I've done? Just fill that in there. Right, so from then, I'm writing in the concentration at equilibrium. Remember, in the question it told me that it takes up a volume of 5 litres. So here I'm going to write in 0.2 minus 2X over 5. Can you see that? Yeah. Then this is X over 5. And then this is X divided by 5 as well. All right, so 5 there because the volume is 5 litres, so I'm dividing by 5 litres to change from moles to concentration, to work out what it is in moles per litre. All right, so now I have an expression for the concentration of chlorine at equilibrium, for the concentration of bromine at equilibrium, and for the concentration of bromine chloride at equilibrium. I have these values here, here, and here, so I'm going to write these in here now, okay? And I'm going to do that by taking the concentration of bromine at equilibrium, which is X over 5, and that's going to be multiplied by concentration of chlorine at equilibrium, which is X over 5, and that's going to be divided by the concentration of bromine chloride at equilibrium, which is 0.2 minus 2X over 5, and that's all squared, remember, because we had a ratio of 2 to 1, so we're going to square that. And I know that all of that is equal to 0.220. So I'm writing that in. So there's my equation. So from here on, it's just maths. It's not chemistry anymore, really, okay? So it's just maths. It looks horrible, doesn't it? But 99% of the time, these equations will simplify easily. And that's the first thing we're going to do, is we're going to simplify this equation. Then we're going to solve for X, and then we're going to check to see what exactly they're asking us in this question. Is that fair enough? So that's always the way these work. You're solving for x, and then after you've solved for x, what you're going to do is you're going to use that value for a certain purpose. So how are we going to simplify this? Well, we don't like fractions on top of fractions. Sure, we don't. So we're going to cancel these 5s. As you can see, this is divided by 5, and there's 2 5s here because these are squared. So we're going to get rid of that like that. And that gives me x squared over 0.2 minus 2x squared equals 0.220. All right. Now, at this point, you can do one of two things. You can solve it using, change this into a quadratic equation. So you can multiply this out and have an x squared plus something x plus a number, and use minus b plus or minus the square of b squared minus 4ac over 2a, which you should be familiar with from maths class and from junior cert maths and all that stuff. You can do that. That's absolutely fine. But there's a simpler way to do this. And the simpler way in this case is just by getting the square root of each of these. The square root of the top, the square root of the bottom, and the square root of this number now. And that's what I'm going to do because it's just easier. So the square root of x squared, surprise, surprise, is x. And we're going to divide that by 0.2 minus 2x. And that's equal to the square root of 0.220, which I got from my calculator, which is 0.469, like that. See what I've done? So I've made this relatively complicated equation a little bit easier now. And now what I'm going to do is I'm going to bring this over to this side and I'm going to solve for x. So like I said, the next bit is pure maths. I'm just going to switch over my my whiteboard here because I'm going to need a bit more space, right? So that's where I was. I was at x divided by 0.2 minus 2x is equal to 0.469. So I'm going to bring this over the equation now over here, and that's going to look like this, right? I'm going to still have my x there, and my x is equal to 0.0938 minus 0.938x. Okay, so all I've done is I've multiplied that by that and this by that there. All right, so I've done that there like that. And now what I'm going to do is I'm going to bring my x's over to one side. So if I bring this over the equation, that's going to be x plus 0.938x plus 0.0938. And literally then I'm just going to add those two values together. I get 1.938x equals 0.0938. Okay, and I'm going to divide that number by that number. X equals 0.0938 over 1.938. And now divide that number by that to get x, and I get x equals 0.0484 moles. That okay? So that's just simple maths, very straightforward. Solving for x, you're all well able to do that. It's not an issue, nothing chemistry related there at all, right? But let's go back and just remind ourselves what x is, okay? So I'm bringing back my other sheet here. This is the table that I have. X is the concentration of bromine, okay? And the concentration of chlorine. And I've now worked that out. That's 0.0484 moles, okay? But the question, and again, you can pause the video and check this if you want, asks me for the percentage decomposition of bromium chloride, okay? So to work out the percentage decomposition, what I need to do is work out how much was used and express that as a percentage of how much we had at all in the first place. So to do that, I'm going to take what was used, divide it by what we had originally, and multiply it by 100. That's what's decomposed, okay? That's broken down into bromine and chlorine. And that's really easy to do. What I have to do is get the value of 2x. I know what x is, so I can get 2x easily. So 2x is equal to 0.0484 times 2 into my calculator. That's 0.0968 moles. There you go. And that is the amount of bromium chloride that got used up. Okay, so the percentage decomposition, and you're used to percentage compositions from the short questions in question 4, the percentage decomposition is going to be this value divided by the total bromium chloride at the start, multiplied by 100. And that is 0.0968 divided by the original, which is 0.2 from the question, and multiply that by 48.4%. By 100. And I get 48.4% is my answer. That's the percentage of bromine chloride that was decomposed. All right, so that's a bit of a tricky one. It's a bit long-winded. In these questions, you're always going to get X, but sometimes what they ask for is not just the value of X, as in this example. They're looking for you to work out the percentage decomposition. That's tricky. You need to think on your feet in the exam, what do they mean? And you need to be aware enough to multiply X by 2 and divide it by the total. But again, good idea to practice a couple of these. I've done a couple of them now. I've done a couple now, but I'm going to put them up over the next day or two, and over the weekend, maybe you might have a go, guys. Okay, hope that helped a little bit. I hope you're all well. All right, take care. Bye-bye.